Hello, everyone. Hope you're all having a great day today. My name is Mikael, and I'm a PhD student at the University of Alberta, currently working as a research assistant at Intel and Asgard team. Today, I have the pleasure to present our recent paper titled Studying the Performance Risks of Upgrading Docker Hub Images, a case study of WordPress. This paper is co-authored with Petr Muzulek and Korpal Bezimer. Also, this presentation is part of ICP 2022. Let's start with some concept related to this empirical study. I start with Docker containers. Containers are standalone lightweight units of software that packages software code and all its dependencies. First, we have the infrastructure and host operating system on top of it. Then we have Docker engine, where on top of that, applications are running in a container in an isolated environment. Then we have Docker Hub, which is Docker's main public registry. Currently, there's been 318 billion Docker image pulls from Docker Hub, 8.3 million repositories, 7.3 million Docker accounts, and 3.3 million Docker installation. This shows the popularity of this technology. Docker images facilitate the deployment of applications in production environment. Users can do in-place upgrades to benefit from the latest released features and security patches. As I said, the Docker Hub contains many repositories for different applications with different versions. The users can simply pull the images from Docker Hub and deploy them as containers in Docker host. Also, users can do in-place upgrades. When a newer version of a specific application is released on the Docker Hub, the user can simply pull the image and deploy the newest version on the Docker host again. However, upgrading a Docker image will change the main application and its dependencies. For example, upgrading the WordPress Docker image will change the WordPress, Apache, and PHP version of the application. And we believe upgrading Docker images may cause hard to diagnose performance issues. Performance testing is not a widely implemented practice in industry or by developers. Our hypothesis is that the same applies to Docker images as well. So that's why we decided to study the performance risks of upgrading Docker images. We selected WordPress application as our uh, target application, and we tried to answer two questions. What is the impact of upgrading the Docker image of WordPress on its performance? And what is the relation between the performance of the WordPress application and updates of its dependencies? So someone may ask, why WordPress? First of all, it's an open source content management system. Then it's been used by more than 35% of the sites across the web. And also, it has more than 1 billion pulls from Docker Hub. Our methodology to study the performance risk of upgrading Docker images includes collecting image information for WordPress, deploying WordPress and identifying dependency versions, collecting and analyzing performance data. To be more specific, in the first stage, for collecting image information for WordPress, we developed a crawler to collect WordPress Docker image tags. We collected 4,153 Docker images for WordPress. And after filtering some of these Docker images, we ended up with 165 filtered WordPress Docker images. In the second stage, by creating YAML files for each Docker image, we deployed them and identified the dependency versions, which resulted in 90 unique application and dependency versions. Then, in the last stage, we ran the load test and collected performance measurements for performing our proposed performance risk analysis. This figure shows the setup for performance testing, and in our experiment, we used 3 virtual machines. We ran the experiments on CyberArk Cloud. We introduced 20 users. and conducted the test for 5 minutes. We repeated the test for 3 times to reduce the impact of cloud variability on our measurements. Also, uh, the VMs are in the same network to minimize the latency. We collected the response time for our performance measurements. After collecting the performance measurements based on semantic versioning, we created patch, minor, major version groups for WordPress and two main dependencies, PHP and Apache. When we say major group, we mean the application has same major version. In minor group, they have same major and minor versions. And in patch group, they have same major, minor, and patch versions. We calculated the relative average response time for doing patch to patch, minor to minor, and major to major upgrades. This is an example for major upgrade. This shows a minor upgrade, and this is a patch upgrade. So now it's time for results and discussion. The first research question is, what is the impact of upgrading the Docker image of WordPress on its performance? This figure shows the relative average response time for all WordPress patch-to-patch upgrades. The last box plot shows all 302 possible consecutive patch-to-patch upgrades for the WordPress application. In 52% of the cases out of 302 cases, patch-to-patch upgrades degraded the performance of the WordPress. This finding shows that we cannot make accurate prediction about the effect of doing an image upgrade on the performance of the application based on the WordPress version of the image alone. In the worst case, we had 9% to 340% performance degradation, and in the best case scenario, we had 5% to 77% performance improvement when doing patch-to-patch upgrade. This figure shows the relative average response time improvement for WordPress minor to minor upgrades. The last box plot in this figure shows the relative average response time improvement for all possible consecutive minor to minor upgrades. In 65% of the cases out of 1,218 cases, minor to minor upgrades of WordPress, the average response time is degraded. So our Mann-Whitney U test shows that the performance risk of a minor to minor upgrade without conducting performance test is significantly higher than for a patch to patch upgrade. The worst case, we had 32% to 354% performance degradation, and in the best case scenario, we had 25% to 79% performance improvement for this case. This figure shows the relative response time improvement for WordPress major to major upgrades. In this case, a major upgrade can result in 400% performance degradation or 78% performance improvement. And also, there is 58% chance of performance degradation. This highlights that conducting a performance test is essential for WordPress Docker images, even in a major upgrade. Summary of our findings for research question 1 is that the wide variation in relative response time improvements for the studied upgrades indicate that it is hard to predict how performance will be affected based on the WordPress version in the image alone. This implies that the performance of the WordPress is mostly driven by other components in the image. Then, in research question 2, we try to answer what is the relation between the performance of the WordPress application and updates of its dependencies. This figure shows the relative response time improvement for PHP patch-to-patch upgrades. The last box plot in this figure shows the distribution of the relative average response time improvement for all consecutive patch-to-patch upgrades of the PHP. Upgrading to the next available PHP patch version degraded the WordPress's performance in 58% of the cases out of 123 cases. Also, This figure shows the relative response time improvement for PHP minor to minor upgrades. The last box plot in this figure shows the distribution of the relative average response time improvement when upgrading all WordPress Docker images with the same PHP minor version to the next minor version. Our findings show that upgrading the minor version of the PHP in WordPress Docker images results in an improved performance in 66% of the cases out of 1,474 cases. Also, we observed that doing a minor to minor upgrade is 58% more likely to result in performance improvement than a patch to patch one. The Man with EU test confirms this difference as well. Also, looking at the box plot on the top, in all studied WordPress Docker images, upgrading an image with PHP minor version 5.6 to one with PHP 7.0 improved the performance in all cases. Taking into account these observations, we can conclude that the main contributing factor to the performance of WordPress image that use PHP 5.6 was the PHP dependency. This figure shows the distribution of the relative average response time improvement for all consecutive major-to-major upgrades of PHP in WordPress Docker images. Performing a major-to-major upgrade of PHP improved the performance of the WordPress application in all 1,241 cases. In other words, selecting a random WordPress Docker image that uses PHP version 5 and upgrading that to another WordPress Docker image with PHP major version 7 results in performance improvement ranging from 54% to 80%. This figure shows the distribution of the relative average response time improvement for all patch-to-patch upgrades of WordPress Docker images with the same Apache patch versions, the next Apache patch version. Upgrading to the next available Apache patch version improved WordPress's performance in 58% of the cases out of 2024 cases, as you can see here. Um, this indicates that it's hard to predict how upgrading an image will affect WordPress's performance based on its Apache version. The summary of our findings for research question 2 shows that it's hard to predict how upgrading a WordPress image will change the performance based on its WordPress or Apache version. Also, a major version upgrade of PHP considerably improved WordPress's performance in all cases, implying that WordPress's performance is highly dependent on the PHP version. During our case study, we observed that none of the official WordPress images mentioned anything about performance or response time. So the users of these images, they have to either resort to other source of information or conduct their own performance tests or even simply take a gamble in terms of performance when doing an image upgrade. We believe that Docker Hub should allow users to provide performance measurements of an image. So yeah, we recommend that Docker Hub should provide a mechanism for submitting the results of the performance test of the offered images along with the image itself. Also, at the time of writing this paper, the types of changes that are allowed by the semantic versioning principle do not cover performance. So, so the performance is increasingly important for software and it's considered the new correctness. We believe that it's a missed opportunity that changes to the performance are not covered by semantic versioning. So we recommend that semantic versioning should be extended to cover performance changes. To summarize this presentation, first I presented our methodology to study the performance risk of upgrading Docker images. Then we answered the question, what is the impact of upgrading the Docker image of WordPress on its performance? Then we answered, what is the relation between the performance of the WordPress application and updates of its dependencies? Then we provided some recommendations. Thank you for watching this video.